Hey guys, so here is what we're working on today. We're going to expand what we're doing with our Lewis structures because the ultimate goal, remember, is to figure out some more physical property of it. Like, can it mix with something, right? So it's polarity. And we're going to talk about that in just a second. So we're going to be talking about molecular geometry today, but we're going to take this really slow because this process can be difficult, especially if you're still struggling with Lewis structures. So if you're still struggling with Lewis structures, my suggestion is that you get some help ASAP, right? Set up a time to work with me this week. I know that we are asynchronous this week, but I'm available almost most mornings except Thursday. So please just let me know what I can do to help. So molecular geometry is this. Not everything's in a straight line. Not everything's in like this perfect shape, right? There's actually lots of different molecular geometries, which we'll look at in 1 second. But these are some of the most common ones here. So these are literally what the molecules look like, right? What the substances actually look like. And what that helps us with is the polarity here. So this blue and green region are telling us if it's a positive or a negative pole. And that polarity, if a molecule is polar or nonpolar, is what allows us to tell if something is going to mix, okay? Like oil and water, or different substances that we might want to try to mix together to make a new compound, right? And so that's what's going to help us. So right now, pause your notes and make sure you write this down because that's a big point that we want to have, is that molecular geometry helps to determine the polarity of a substance. Knowing the polarity helps us predict if two substances will mix. Pause the video real quick. So then from there, we can talk about these VSEPR geometries, the molecular geometries. So these are most of the shapes that we could have. You can see we can have everything from the bottom here is octahedral, square pyramid. Like, these have actual shapes, what they look like, and that's what we're going to talk about over the course of the next couple weeks, right? Is this molecular geometry here. So we're not going to use this yet. We're going to look at the VSEPR geometries tomorrow on Wednesday. And use this sheet, but this is a reference sheet. If you want one printed, let me know and I will try and get that out to you. You also can just grab the link. I can send you the link and you can print it at home if you have a printer there, or you can use the soft copy. That is completely up to you, but this is like an addendum to your reference table. It's another piece of your reference table that you're going to want to have to make sure that you have everything. I won't ever make you memorize the molecular geometries unless you decide to take AP Chem. Then you have to memorize them. So we're going to look at a few examples about how to create ax notation. To create an ax notation, it's really simple. You're just using the Lewis structure that you actually drew in order to find the number of central atoms. So you would put a number right here, like a little subscript. We will only ever work with one central atom. So this would always be 1 here. The x is how many terminal atoms we have. Terminal atoms are, let me back up, these guys, the X is here. So that's why it's X, right? So this is our terminal atoms. And so you would count how many and put a subscript here. And then E is the number of lone pairs on the central atom, okay? If you look back at the sheet, the reference sheet, the central atoms are E. So we're looking for how many lone pairs are sitting on there for E, okay? So we would always just put subscripts here. Those subscripts are what's going to help us to identify the type of shape that we have. But we're just learning the structure of ax today and like how to do it. And we'll look at how we use ax tomorrow to identify the shape, okay? So go ahead and click on to the next video because we're going to do a few of these together.